Hello everyone. In today's mini lecture we're going to be discussing the last page on your resource packet. So under the Google Classroom, under your classworks, if you go to the tab that's entitled Resources, it'll say Chemistry Resource Packet. And the very last page of that document is the hydrogen Borhs diagram. So before I go through and discuss it, I need to tell you a little bit of background about the electrons. So you know that the nucleus is surrounded by energy levels, and that's where the electrons are going to be located at. So what happens is, if electrons are given energy, they can move their position within those orbitals. So the more energy they have, then the higher they can move up in higher orbitals. So if it is just the normal energy, just what you would find in everyday circumstances, then the electrons will occupy the energy of what allows them in whatever orbital it is. That is called their ground state. That's where they naturally are located. But if I give them energy, then they have the ability to move up. Now, you can't give a little bit of energy and they move a little bit. What happens is you will have one packet of energy, and one packet of energy is called a photon of energy. If you give an electron one photon of energy, it will move one energy level. If I give it 2 photons of energy, then it's going to move 2 energy levels. And if I give it 3, it'll move 3. Now the thing about it is the energy has to continually be given to that and provided to allow it to sit at those excited states. Once that energy is no longer being provided and it's no longer continually, then that electron now will go back to its original state. So if you are going from a lower to a higher energy level, it has to absorb energy. If you're going from a higher energy level and it's dropping down to a lower energy level, then that energy is being given off. The energy that is absorbed is called a photon. It can be in all types of different means. It can be heat energy from, like in our virtual lab yesterday, it could be heat energy from a Bunsen burner, it could be electricity, it could be friction energy, any of those, anything that can provide that energy. If it can provide one photon, it can move up. But now, when the electrons go back down to their original ground state, they're given off a very specific amount of energy in very specific ways. And that is what we're going to address in the following diagram. So let me show you what this looks like. Here's my nucleus. First energy level, second energy level, third, fourth, fifth. So if you look at it, I'm just going to choose this first one that I come to, that dot right there. That represents an electron. That electron is on the fourth energy level, and if you look, there's an arrow pointed back to the first. So it went from the fourth energy level, and it drops down to the first. If that happens, it is going to emit UV light, which is ultraviolet radiation. So ultraviolet is from right here. Now let's pick another one, and we'll pick this one right here. And that is on the fourth energy level, but this time it's going to drop to the second energy level. So if it goes from the fourth to the second, I can follow it down. I do have the wavelength. The wavelength is 486, but it's visible light. Visible as what we see, the Roy G. Biv, the rainbow of colors. So now I move over and I go from, and I'm just going to look at this one right here, and it goes from the fourth to the third. Anytime that you drop back to the third, it gives off IR, which is called infrared. So before I go any further, just look at your electromagnetic spectrum. And the electromagnetic spectrum says that we go from left to right, from least energy to more energy. And when we're talking about the electrons and the energy they give off, it's all going to be right here. The infrared, the visible, and the ultraviolet. So let's go and look at a couple of examples. I can ask you a couple of different types of questions. I can first ask you the type of energy that is being released. So if I go from the fourth to the first, I follow that down, the type of energy is ultraviolet. So the type of energy is either infrared, visible, or ultraviolet. The second thing I can ask you is the actual wavelength that's being produced. So I go from, again, from the fourth energy to the first, I look at it, 97 is going to be the measurement of the wavelength. So there's two types of questions that I can ask. I'll either ask the type of energy or I'll ask you for the wavelength. Now I told you there was three questions. The other one is what happens if you have one in the visible? And I'm going to pick one that we haven't done yet. I'm going to go from the third energy level to the second energy level. So here's my third. I come around. First dot goes all the way to fourth. I'm not looking at that one. Here, right here. You see this dot right here? It's on the third energy level, and it's going to the second. So the wavelength is 656. What type of energy is it? Visible. Now, if it is part of the visible spectrum, I could also ask you, hey, what color is that? So in order to answer the colors, we're going to have to come all the way down to the bottom. You see the very bottom down here? It says red, orange, yellow. That's the Roy G. Biv. That's the spectrum. So the easiest way to look at that was, we said that it was 656. Think about putting it in scientific notation. 6.56. Don't worry about times 10 to the whatevers. Just say 6.56. It's going to align with the numbers down here. So where does 6.56 fall? Well, I look at this, and here's 6.5, and then we're going up, so it would be right in here. So what color would that be? It would be a reddish orange. It would kind of be more red and then to the orange because we're way over here. So that would be it. So if I said, well, what would 486 be on the visible spectrum? 4.86 would be somewhere right in here, so hey, that'd have to be blue. So now we have three types of questions that we can answer from our Borhs diagram. All right, so let me tell you in recap, in conclusion, what have we done in today's mini lecture? Number one, we talked about a photon of energy. A photon energy is needed to be given to an electron to get it to move up in energy levels. As soon as that electron moves up, it's going to lose that energy. It's going to drop back to its ground state. So we've got two terms. We've got the ground state, that's where it's naturally found, the excited state, where it would be found as the energy is being added to it. Then we went back over and said, okay, let's look at the hydrogen Borhs diagram. What would happen if I went from one level to another level? And I can ask you two primary questions. The first one is the type of energy. That's going to be your infrared, your visible, or your ultraviolet. And the second one can be your wavelength. And the wavelength are the actual numbers, like 656 or 97. If it falls within that visible spectrum, then I can also ask you the third question, and that's going to be, what color is it? And to find the color, I use the scale at the very, very bottom. So I hope this will help you in completing your next worksheet, and you can fill that out and put it into your digital notebooks. Thank you.